Assalamualaikum warahmatullahi wabarakatuh. My name is Nofaradina binti Muhammad Karim Faisul. Today we want to present about guidelines on occupational safety and health for design, inspection, testing and examination of local exhaust ventilation system. This is my group members: Muhammad Iqbal Hafiz bin Rumaizi, Nur Syafiqah binti Manawi, Nur Syamimi binti Muhammad Zamari and Rajesh Shazani bin Raja Mansur. Introduction of local exhaust ventilation system is one type of engineering control equipment that prefers and commonly used in workplace to control exposure to chemical hazard to health. Local exhaust ventilation system operate on the principle of capturing a contaminant at or near its source before they are dispersed into the workroom environment. LEV adverse health effect can occur when workers are exposed to occupational hazards such as dust, smoke, and vapor, or chemical biological agents. To have an effective ventilation system, it must be properly planned and installed and must be used properly and cared for properly. Employers are also tasked with working with designer, supplier, and employees to ensure effective control. Suppliers must be provided appropriate LEVs in order to function properly and continue to function fully. Employees must be given training in its use and maintenance to understand its proper use and effectiveness. It can cause poisoning such as carbon monoxide and so on. Control or lack of general ventilation, including supplying and general exhaust ventilation, can affect LEV performance, although these guide focus and local exhaust. For example, draft from open doors can challenge the extraction performance of welding hood. A local exhaust ventilation system comprises of up to 6 basic elements. The basic elements are hood, duct system, air cleaner, fan, exhaust duct, and makeup air. The purpose of the hood is to collect the contaminants product in the airflow directed towards the hood. The hood is the most important component in local exhaust ventilation system. This is due to the local exhaust ventilation system will not be effective if contaminants are retained or captured by the hood, as to ensure that the concentration of contaminants in the workplace is below acceptable limits. Hood can be categorized into the three categories, namely enclosing hood, receiving hood, and capturing hood. Enclosing hood. Enclosure hood are hood that surround the contaminant source as much as possible with wall and doors with minimum opening area. The hood may also form a total enclosure around the source of contaminants. For example, fume boards, asbestos debagging boards, and spray painting boards. For receiving hood, these hoods are designed to receive or capture emissions from sources that have the initial speed of movement as well as capture contaminant in the workspace and located close to the source of contaminant and do not cover it. For the example of the racing hood is siding hood, slot hoods, bottom hoods, and canopy hoods. So for the third category is capturing hood. Capturing hood is the source is external to the hood and the airflow must generate sufficient velocity and the source of reach out and capture the contaminant. In general, many issues can reduce performance of capturing hoods, such as cross-draft and use placement. Next, ducting system. A ducting system is a network of ducts that connect the hood and the component of the local exhaust ventilation system. The duct system transport contaminant air to the air cleaner. Ducts on the fan outlet usually discharge the air to the atmosphere. The duct system must be carefully planned and without the slightest negligence of minimized loss. This is so that airflow can pass through the ducts with little friction or resistance. If a quantity of air enters a duct whose surface is small, then the pressure applied is high. Air that moves too slowly will allow contaminants such as dust to settle and accumulate. When the particle accumulate, air cannot enter the ducts and this particle will eventually clog the duct. Duct system typically require large amounts of air to move contaminants in relatively small amounts. The volume of airflow required depends on the acceptable concentration of air pollution in the workspace usage. Reduction of flow in the ducts will cause dust to settle in the ducts and resulting in plugging problem, and this will reduce rate of suction at the hood. Air cleaner. Air cleaner is a device to remove contaminants that are carried in the contaminants air from hood which cannot be discharged into the community environment or to recover materials that have a salvage value. The air cleaner of the air filter must be well designed so that it can be easily connected or disposed of without effective flow performance. Air filtration or air cleaner must be easy to shape, change, or easy to clean and maintain without causing exposure to maintenance operation. The increase in exposure potential depends on the type and complexity of the air cleaner system in which it works. It may be necessary to arrange the procedures so that the filter air is safe for entering the filter house and for periodic filter replacement, cleaning, and maintenance. Fan is the air-moving device that provides the energy to draw air and contaminants into the hood by including a negative pressure or suction in the ducts leading to the hoods. The fan convert electrical power or other form of energy into negative pressure and increase air velocity. The fan must overcome all the loss due to friction, hood entry, loss in the ducting system, and loss due to the air cleaner, while producing the required flow rate that is enough to extract and transport contaminants air. There are two main types of exhaust fan: axial fans and centrifugal fans. Axial fans are fans that can cause gas to pass through in the axial direction where the blades will rotate. The flow is axial during entry and exit. This is between 2 to 6 blades. Centrifugal fans is a fan that looks like a squirrel cage. This fan will draw the air to the center of the fan and will emit clean air at a 90-degree angle. This fan is also one of the two fans used in the ventilation system. For axial fan consists of three types of fans. Among them are propeller, tube axial, and vane axial fans. A propeller fan is a fan that is often used for ventilation or liquefaction cooling. These fans are also often mounted on wall or ceiling. A common example is your vehicle's radiator fan or a freestanding space fan. Propeller fans are designed to move large volumes of air at low static pressure. Tube axial fan is a fan which is used to remove air from the inlet. This fan consists of many blades on the surface on the cylinder. The blades as will study the shape like air pioneers, where it can help the movement of air in and out. The diameter of the hoop used can only be 30 to 50% of the outlet diameter of the blades. Vane axial fan is very similar to a tubular axial fan in that the fan has a housing containing a propeller guide. This propeller serves to restore the tangent airflow velocity from the fan blades. The hoop diameter from this axial fan is large in diameter than the outlet blades fan, which is 50 to 18%. The axial vane fan is suitable for use for high static pressure conditions. For centrifugal fan anyway, there are main types of centrifugal fan. Forward inclined blades, backward inclined blades, and straight radial blades. Forward inclined blade. This forward curved fan is ideal for low speed application and has low pressure. Among them are such as domestic furnace, central situation units, and swollen air conditioner. The construction of the impeller, shaft, bearing, and smooth front curve fan housing limits its suitability in industrial application. In addition, the blades are curved in the same direction as the wheel rotation. For backward inclined blade, the fan consists of 3 standard blade types for his fan. This fan also includes curved single thickness, and curved air saddle. Apart from being large and heavier, this backward inclined blade is also designed to stay removed from wheel rotation. The most operation of his fan is that this fan can manufacture the very best speed and is considered more efficient than all other form of fan. The backward inclined blade fan is the best option for air mass and high volume application. Backward inclined blade have lower structural strength and efficiency. They are easy to produce due to the elimination of the blade curvature. For straight radial blades, the centrifugal fan, which is a radial blade fan, is also referred to as a pedal wheel fan because the impeller has many flat blades that are the same distance, that is by extending perpendicular to the direction of rotation of the wheel. Is it also narrow and deeper compared to the blades tilted forward and backward. This fan produces medium to high pressure and can move a high mass or volume or liquid, and this fan is very suitable for material handling. For hood design parameter in visibility must be sufficient enough to ensure contaminants air would not leak out of the hood. For the size of enclosure must be large enough to accommodate contaminants air. Rate of flow with a hood must be equally distributed as to ensure there is no null point. This can be achieved by installing guide such as baffle or plenum. The location and position of the hood must ensure the hood does not interfere with the task that worker has to carry out. The system design parameter inflow in the ducts must transport velocity be sufficient to overcome energy losing along the ducts to avoid clogging. For duct material must be able to withstand abrasion and corrosive material. For shape and size, the round duct is preferring the rectangular ducts because more energy loss in rectangular ducts. In fitting attached to drawing system, its damper cannot be temperature by worker. For the design parameter air cleaner, in contaminants characteristic, we must design a form of air cleaner by determining first the type of air purify of the use with a contaminants. We must also take care of other dust particle such as dust from wood, from some machine or no other types of dust, the contact fragment that can cause an explosion. Second, the amount of contaminants extracted will determine the size of the air cleaner required. So the number of contaminants extracted will be determined by the size of the air cleaner required. The greater the number of contaminants extracted, then the larger the size, pollution can adversely affect factory workers and other occupants. Efficiency of the air cleaner will determine the amount of contaminant still remain in emission air to the environment. For pressure loss will determine the amount of energy of auxiliary energy required at the fan. Fan design parameter fan curve. Three curves that can be used to describe the performance of a three-area static pressure curve, brake horsepower curve, and mechanical efficiency curve and static pressure curve will indicate the quantity of air that the fan will deliver at a given rotating speed depends on the resistance it is working agent. For material handled through the fan, we will determine the type of fan selected. Location and position. The size of the location also will determine of type of fan to be used. Fan pressure requirement to overcome overall resistance of the system and then expressed as fan static pressure or total fan static pressure. That's all for me, so we will continue with my friends.
My name is Shafika Binti Manawi, so I can proceed this presentation with legal provision. The first one, Regulation 2000. Engineering control as any equipment which is used to control exposure of employees to chemical hazards to health. And the second one, Regulation 17. Engineering control equipment has to be inspected at an interval not longer than 1 month. And the third one, Regulation 18. Logger-house ventilation system has to design according to approved standard by registered professional engineer. And the last one, Regulation 19. The type of record the employer has to keep and produce for inspection when requested by Director General of Occupational Safety and Health.
So I will continue for the next part. The next is approved standard for design of local exhaust ventilation system. So we see the inputs. So first, ventilation system purpose. There are four here. So first is provide ongoing provision of fresh outside air. Second is maintain comfortable temperature and humidity. Third is reduce potential fire or hazard of explosion. And the fourth is remove or delete pollutant from the air. Okay, so the next part is basic. So the next part is basic ventilation system types. So here there are two: dilation, decrease pollutant concentration by mixing polluted air with clean uncontaminated air. And second is local exhaust ventilation catch and exhaust contaminant at or very near the surge. So for the main dilation ventilation characteristic is number one is dilation and exhaust huge amounts of air from into a region of building or general ventilation supply. For second, dilation ventilation controls the pollutant generated by ventilating the workspace at the workplace. The third is dilation ventilation may be made more efficient if the exhaust fan is positioned near exposed personnel and the maculation air behind the worker is located, which is to remove polluted air from the respiratory area. And the fourth is the dilation must be restricted to conditions in which chemical contaminants are contained. So let's move the other part. So local exhaust ventilation components. So here we will see there are 6 basic elements in local exhaust system. So number one is a hood or a hood which traps the pollutant at the surge. Second is goods transport by airborne chemicals. Number 3, an air cleaner that eliminates the contamination from the system moving air. Fans that move through the system release exhaust air open air. And number 5, an exhaust stack that release contaminate air. And the last one is make the air that substitute for the exhaust air. So we continue the other part. So for the ventilation system limitations, there are certain limitations include. Number 1 is system deteriorate with time due to the build-up of contaminant in the system, in particular filters. Number 2 is to discover problems yearly and execute corrective steps. Regular and routine tests are necessary. And the last is only qualified individuals should change the ventilation system to ensure that the system continues to operate efficiently. So basically here there are many design standards, so I will choose 4 here. So the example is the Ontario Occupational Health and Safety Act, the Industrial Establishment Regulation Act 51, Section 127 and 128 stipulate general ventilation and air substitution requirements. And the second example is OSHA. The building standard of OSHA in 29 CFR 1926 contain welding ventilation standard. And the third is NIOSH. A number of useful ventilation documents have been published, including publication on foundry ventilation, recalculation, and push-pull caps. And the last example I put here is ACGIH, the manual on the recommended practice for industrial ventilation published by the ACGIH Industrial Ventilation Committee. The manual is a useful search of information on all aspects of IVS worldwide. So this 4 is level of design standard. So there are many, just put 4 here. Okay, we go next to duct system. What is duct system? The ventilation system in building includes air moving equipment like fans and blowers and a network of pipeline to remove the polluted interior air from the exterior of a structure. So we continue. What is duct system? Okay. So basically here we have principle of duct design. So duct system should be constructed to have a low friction or resistant air movement through the ducts. The quantity of air via a conduct relies on the cross-section area, the open area of the conduct and the air velocity. So they are designed for use easily airflow, and you must avoid design that cause more resistance to airflow. So this is principle here. Okay, so we continue to the fans. So fans, a good ventilation system requires the right size and kind of fan to collect pollution at the surge, pull them through the hood, transport them via the duct system, air cleaning equipment, and out to the outside. There are 2 types of fans here, the axial fans and the centrifugal fans. The axial fans draws air directly through the fan, and centrifugal fans pull air into the center of the fan and expel it at a 90-degree angle. So let's move the other part. So material touched by the fan. So if there is a little quantities of smoke or dust in the exhaust air, a reverse centrifugal or adjuvant should be used. So the second, if exhaust air includes light dust, smoke or moisture, it should be preferable to use a reverse or radial centrifugal fan. And the third, if the exhaust air particle load is large or when the material is handled, a radial centrifugal fan is the usual option. If the exhaust air includes explosive or compatible material, it should be chosen for the spark-proof engine. And the last, if the exhaust air includes corrosive pollutant, it may be necessary to employ a protective coating or specific building material in fan and engine construction. So this is the last part. So hood is the point where polluted air is pulled into the ventilation system. Hoods are intended for particular activity or circumstance in size and forms. The airspeed at the hood opening and within the hood must be sufficient to collect, detect and transport air pollutants. So here the three common categories of caps. There are three. So the first is inclusion. Hood enclosures or smoke caps are hoods around the process or the location of pollutant. The glove case and grinder hoods are examples of fully enclosed hood. So this is the examples of the diagram. Number 2 is receiving. These hoods are intended for receiving or capturing emissions from a surge with a certain starting speed or motion. For instance, the reception cap type known as a canopy cap absorbs or rising air and gas as illustrated in figure. So this is the figure of contaminant rising from hot process. And the last is capturing. These hoods are placed near an emission surge without the capture. Example include a rectangular hood on the side of a tank, or a hood on isolation, or a green vegetable in figure. So this is the figure. So that's all for me. So I will continue for the other member. Thank you.
Assalamualaikum, my name is Nur Shamini and I will present my part for assignment 1 is inspection, testing and examination of local exhaust ventilation system. Because every local exhaust ventilation system should be inspected, tested and examined at regular interval to make sure the system works properly and efficiently. So, for the inspection of local exhaust ventilation system should be done a minimum of once a month by the regulation or at a shorter interval as specified by designer to make sure the system functioning properly and effectively. Then are often by any individual that has been taught that procedure to carry out the inspection. So for the inspection of local exhaust ventilation consists of first inspection of vigor of all components of local exhaust ventilation system. Second, identify anything which will be obstruction of flow. Third, maintenance of the fans motors. Fourth, smoke tube tracer. Then, observation of condition surrounding and near the hood. Then lastly is inspection on the filter device. So next, we go to the testing and examination of local exhaust ventilation system, where it need to be carried out a minimum of each 12 months or at shorter interval as specified by the designer. It's to figure out the effectiveness and efficiency of the local exhaust ventilation. So, we go to the testing and examination of local exhaust ventilation system consists of first, inspection of local exhaust ventilation, second, determination of duct or duct static pressure along the ducting system, third, determination of hood static pressure, fourth, determination of hood velocity pressure and transport velocity, then determination of capture of phase velocity, and lastly is determination of air cleaner's efficiency.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Kual Hafiz bin Waizi. Now I'm going to present about assessment of efficiency of local exhaust ventilation. Assessment of the efficiency are often done by analyzing result of inspection, testing and examination of local exhaust ventilation that mentioned before. Result of physical inspection and observation while the system is operational are vital within the assessment of the system. The smoke tube test will show how and where contaminants are escaping from the hoods into the workroom and therefore the effect of cross-draft. The planning of the hood is extremely important because the efficiency of the hood are going to be affected. A assessment is administered by comparing the result of the measurement with baseline data and standard. The result required higher than 10% to look after the planning specification or below. The quality indicate that there's something wrong with the system, and further investigation and analysis got to be administered to work out the explanation for the matter. Um, that's all for me.
For the conclusion, local exhaust ventilation system operate on principle of capturing a contaminant at or near itself before they are dispersed into the workroom environment. Contaminant can be in the form of dust, smoke, mist, aerosol, vapor, and gas. Effectiveness and efficiency of the local exhaust ventilation system depend on design, regular maintenance, proper usage, and regular inspection of the system.
So that's all from us. Thank you.